Section 2.4, Significant Figures and Calculations. Let's begin by reviewing the last section. Table 2.4, Significant Figures and Measured Numbers. A number is a significant figure if it is not a zero, so 4.5 grams is two significant figures. It is not a significant figure if it is one or more zeros between non-zero digits. So 2.205 meters is three significant digits. A number is a significant figure if it is one or more zeros at the end of a decimal number. So 50 point is two significant digits. 25.0 is three significant digits. A number is a significant figure if it is in the coefficient of the number written in scientific notation. So 4.8 times 10 to the 5 kilograms is 2. 5.70 times 10 to the negative 3 meters is 3. Number 2, a zero is not significant if it's at the beginning of a decimal number. 0.0004 seconds is one significant digit. 0.075 centimeters is two significant digits. A zero is not significant if it is used as a placeholder in a large number without a decimal point. 850,000 meters is two significant digits. 125,000 grams is three significant digits. In the sciences, we measure many things: the length of a bacterium, the volume of a gas sample, the temperature of a reaction mixture, the mass of iron in a sample. The numbers obtained from these types of measurements are often used in calculations. The number of significant figures in the measured numbers determines the number of significant figures in the calculated answer. Using a calculator will help you perform calculations faster. However, calculators cannot think for you. It is up to you to enter the numbers correctly. Press the correct function keys and give the answer in the correct number of significant figures. Rounding off. Suppose you decide to buy some carpeting for a room that measures 5.52 meters by 3.58 meters. Each measurement of length has three significant figures because the measuring tape limits your estimations to a place of 0.01 meters. To determine how much carpeting you need, you would calculate the area of the room by multiplying 5.52 times 3.58. If you need a calculator, the display shows the numbers 19.7616. However, the display has too many numbers, which is a result of the multiplication process. Because each of the original numbers has three significant figures, the display numbers of 19.7616 must be rounded off to three significant figures, 19.8. Therefore, you can order carpeting that will cover 19.8 square meters. Each time you use a calculator, it's important to look at the original measurements and determine the number of significant figures that can be used for the answer. You can use the following rules to round off the numbers in your calculator display. Rules for rounding off. If the first digit is dropped, is a 4 or less, then it and the following digits are simply dropped from the number. If the first digit to be dropped is 5 or greater, then the last retained digit is increased by 1. For example, 8.4234, three significant figures, is 8.42, drop the 34. 114.780, 148, drop the 80 and increase the last digit by 9. Multiplication and division with measured numbers. In multiplication or division, the final answer is written so that the same number of significant figures as the measurement with the fewest significant figures. Some examples rounding off the numbers from multiplication division follow. Multiply the following measured numbers: 24.65 times 0.67. Calculator answer is 16.5177, but there's only two significant figures in 0.67, so it has to be rounded to 17. Because the calculator displays more digits than significant figures in the measured numbers allow, we need to round off. Using the measurement that has the fewer numbers, 2, of significant digits, 0.67, we round the calculator display to 2 significant figures. Example 2. Perform the following equations with measured numbers. 2.85 divided by 0.3741 times 1.50. The problem with multiple steps is worked on a calculator by dividing the number in the numerator by each of the numbers in the denominator. The calculator display is 5.07885559, but the lowest significant figures is 3. 2.85 has 3, 1.50 has 3, and so you round to 5.08, 3 significant figures. The calculator display is rounded off to give an answer with 3 significant figures, 5.08. Adding significant zeros. Sometimes a calculator display contains a small whole number. Then we add one or more significant zeros to the calculator to display the answer of correct numbers of significant figures. For example, suppose the calculator displays 4, but you used measurements that have 3 significant digits. Then 2 significant digits are added of 4.00 as the correct answer. Addition and subtraction with measured numbers. In addition and subtraction, the final answer is written so that the same number of decimal places as the measurement having the fewest decimal places. Some examples of addition and subtraction follow. 2.367, which is to the thousandth place, plus 34.1, which is to the tenth place. The calculator answer is 36.467, but since your lowest one is only to the tenth place, you have to round it to the tenth place, 36.5. Subtract 2.55 minus 175.65. Calculator answer is 79.35, but since your lowest one is only to the ones, your answer can only be rounded to the ones place, 79. When numbers are added or subtracted to give an answer ending as 0, that 0 does not appear after the decimal on a calculator display. For example, 4.5 minus 2.5 is 12.0. However, when you use the subtraction on your calculator, the calculator display shows 12. The correct answer, 12.0, is obtained by placing significant 0 after the decimal point. 14.5 grams minus 2.5 is 12. But since they all go to the tenth place, you have to round it to the tenth place, which is 12.0.